These 5 devices that are AI-powered help amputees walk again. An artificial device known as prosthetic typically serves as a replacement for a missing body part that has been lost due to trauma, illness, or accident. It is designed to restore the capability of the lost body part. Each year, the prosthetics industry develops more quickly, and in order to create more functional artificial limbs that can make amputees and those who are paralyzed live more comfortably, a lot of people such as doctors, engineers, and students are all working together. In this video, we'll talk about the technologies that allow amputees to lead once more normal lives. First is the Hero Arm, a prosthetic arm made by Open Bionics. This technology is the world's first 3D printed bionic arm to receive medical approval. It is a cutting-edge prosthetic arm that is suitable for kids and adults. It is renowned for having innovative, logical, and strong features. Hero Arm gives users a sense of realistic control over their own muscles due to the sensors inside the socket of the bionic arm. This technology operates by detecting the muscle movements and then activating the hand to respond accordingly. This means that the same muscles used to move a biological hand are also used to move the prosthetic hand and fingers. Additionally, the device is relatively simple to learn, which is essential for any amputees undergoing rehabilitation. With the use of this technology, amputees can now change clothes, open doors, type on a keyboard, eat, and even hold pencils all by themselves. However, using the technology is not recommended for dangerous circumstances or any severe activity because there is a possibility that it will malfunction or the battery will run out. The Hero Arm is the most reasonably priced multi-grip prosthetic arm in the world. It is also lightweight and has empowering aesthetics. Additionally, it is designed and produced in the UK and is offered in more than 800 places across the USA, UK, Europe, Australia, and New Zealand. Adults with below-elbow amputees and kids ages 8 and up can use this. Next is the Bionic Leg, made by the University of Utah. Tommaso Lenzi, an associate professor of mechanical engineering at the University of Utah, and his students created the Utah Bionic Leg, a motorized prosthetic for amputees of the lower limb. By developing prosthetics that can think independently, the University of Utah is adopting a totally different strategy. Given how quickly robotic and AI technology is developing, they incorporate it into amputee prosthetics as well. Lenzi's Utah Bionic Leg gives amputees the additional ability to get up, sit down, and walk up and down stairs and ramps through the combined power of motors, processors, and cutting-edge artificial intelligence. Normally, amputees have to overuse their upper body and the intact leg to make up for the absence of support from their prescription prosthetics, but with this technology, it would be easier for them to do the tasks. The Utah Bionic Leg will enable amputees, especially the elderly, to walk over longer distances and gain new levels of mobility. The team's leader, Dr. Lenzi, set 2 goals. First, he wanted to design a prosthetic that is lighter and more powerful than a real human leg. Secondly, create a leg that is self-aware and can move naturally in any circumstance. But you might wonder, how is that even possible? Well, if the individual walks quickly, the bionic leg will also move quickly and provide the person more energy. In some cases, it automatically adjusts the stairway step height, or it might aid in overcoming obstacles. Before we continue, if you've come this far in this video, give it a like, share, and subscribe. Or let us know what you think in the comment section. The third device is Mr. Burkhardt's brain implant. The spinal cord injury Ian Burkhardt had after the accident in the supposedly fun swimming activity in the summer of 2010 stopped him from walking, limited the range of motion in his arms to his shoulder and bicep, and caused him to nearly totally lose his sense of touch. Burkhardt entered an experimental program called NeuroLife at Battelle a nonprofit research institution in Ohio, after spending years trying to adjust to his injury. In order to increase the range of action in his arms and stimulate his sense of touch, a tiny computer chip had to be implanted in his brain. Burkhart believes the risk was worthwhile because of the potential reward. At Ohio State University's Wexner Medical Center, Burkhart's brain-computer interface, or BCI, was surgically implanted. The tiny, rice grain-sized chip tracks electrical activity coming from Burkhart's primary motor cortex, the part of the brain in charge of voluntary movement. With a small chip implanted into his brain and through the computer that is connected to him, he was able to acquire basic movements through repeated thought training. The device is somewhat like AI, it's just that it's still Ian's brain conducting the training. For instance, whenever Ian wants to open his hands, neurons in his head release the instruction, but because of spinal damage, the signals cannot travel to his hands, which will do the movement. This is where the magic of the chip takes place. The implanted chip picks up the instruction and provides the information to the computer. Once Ian's messages are understood by the computer, it may send a command to a device that is linked to his hand, causing the hand muscles to move. Although this device isn't quite a bionic prosthetic, it does give paralyzed people accessibility to their formerly paralyzed limbs. However, it should be noted that the technology can only perform really basic actions and tasks. But in the years to come, individuals like Ian might be able to regain full use of their arms and legs, and they might even be able to walk once more. Lastly, we'll talk about Össur's mind-control bionic prosthetics. It should be emphasized that Össur, the world leader in non-invasive orthopedics, was the very first company to produce mind-control bionic prosthetics. In fact, Össur gave 2 amputees the first prosthetic legs that could be controlled just by thinking back in 2015. Since then, their technology has become more intelligent. Typically, users of bionic prosthetics must exert some amount of cognitive awareness or deliberate thought, but Össur's smart limbs are capable of performing all the thinking themselves. The clever bionic legs can adapt to the user's walking style, pace, and the environment through real-time learning, resulting in a smooth and simple user experience. The device mimics how the body converts electrical impulses into particular muscle movements by detecting natural movement signals. Additionally, sensors built into the existing muscle tissue collect electronic impulses from the brain and translate them into necessary bionic limb movements. And with this seamless process, the user of the prosthetic can move flawlessly and instantly. Users of Össur's technology no longer have to deal with the injuries caused by traditional prosthetics or make equipment adjustments, which is also a key feature of the technology. That is all that we have for this video. Which of the aforementioned devices would you advise someone to need to use and why? Let us know in the comments section. If you enjoyed this video, click the like and share icons. Don't forget to subscribe and click the bell icon to stay updated and notified when we post videos like this one. We appreciate your time and see you at the next one.